Okay, we're going to talk about a different way of solving these problems. It's basically the same idea, but we're just going to come at it from a different direction. So let's go back to our first problem. We talked about the pipe problem. So if you recall, the city decided it needed sewer pipes, and those pipes needed to have a strength of greater than 2400 psi. So we did a hypothesis test, set up a hypothesis test here of the mean was 2400, and our alternate hypothesis is greater than 2400. This whole thing we want to do at a level significance of 0.01. So tests were conducted, say, by the city on 50 pipes, and they got an average on those pipe strengths of 2460. So is this good enough? Well, the next step in our hypothesis analysis was calculating a test stat, and we use Z here because we had the standard deviation for the population. So we can make this calculation and put the numbers in, and we came up with a Z equals to 2.12. Okay. So the idea here then is we have right-tailed test, and this is our critical region. So Z critical equals 2.33. Then we checked our actual Z value, our test value, and it was 2.12. So we concluded that for this right-tailed test, since ZT is less than Z critical, we do not reject. Okay. Well, another way to look at this, instead of comparing the Z values, we can compare the areas. We can compare this purple area, which, if you recall, is alpha, equal to 0.01. We could compare it with this area. And if we see that this red area, so this is the area to the right of 2.12, we call this P, the P value. If this area is larger than the purple area, we would not reject. If the area is smaller than the purple area, so essentially our Z test is going to fall in the critical region, and if a Z test falls in the critical region, you can see that the tail area to the right of our test stat would be smaller than the area of 0.02, we would reject the null hypothesis. So let's follow through on that idea. So let's figure out what this red area is. So the P method involves calculating what that red area is. So if I have a Z equal to 2.12, then my area to the right of that Z is 0.0174. So how did I get that? Well, I went to my Z tables here. I look at 2.1, 01, 02, and I found this value here, 0.983. So that means the area to the right of this 2.12 is 0.983. But I want this area to the left, so I have to take 1 and subtract this. So if I do that, I end up with 0.017, as you can see here in my calculator. Let's subtract off this 4. So since then that area is greater than 0.01, we then make the same claim we did before. We do not reject our null hypothesis. So it's the same idea, except now we're using the area here, and we're comparing the size of the area as opposed to the value of z. Okay, let's try another example. A researcher claims that the average wind speed is 8 miles per hour, with a standard deviation of 0.6 miles per hour. A sample of 32 days gives us an average of 8.2 miles per hour. So our sample average is 8.2. Calculate the p-value and determine if enough evidence exists to reject this claim. Well, we set this up the same way we set up our hypothesis testing in the past. We start out with step 1, come up with a null hypothesis. And of course, the claim is 8 miles per hour, so the mean equals 8 miles per hour is our null hypothesis. Our alternate hypothesis is going to be a two-tailed test then, where it could be either greater than or less than. So it does not equal 8 miles per hour. Okay, so we need to figure out our test statistic here. So if you're using a z-test here, you're correct. And see if you can do the formula. X bar minus mu over sigma divided by square root of n is our formula. So let's put the values in. Well, our sample mean is 8.2. The mean in the problem is 8. Our population standard deviation was 0.6 divided by square root of 32. And that gives us a value of 1.89. So that means, since we're going to do a p-test here, we want to figure out what the area is to the right of 1.89, and we need to figure out what the area is to the left of 1.89, of minus 1.89. Okay, so we're going to find our p-value now. Well, the area I'm going to choose this area to calculate because I can pull that directly off my z chart. In the area to the left of 1.89, so this area I pop over to my z tables, and you can see that this gives me the area directly. If you look at the z table here, it gives me the area directly to the left of z. And the reason I chose the negative is because I know this is symmetric. The area on the right is going to be the same as the area on the left. So I'm just choosing the area on the left. So minus 1.89 is this value here of 0.0294. So the area is 0.0294. Now, since that would be our p-value if this was a single-tailed, a left or a right-tailed test. But since this is a two-tailed test, the p is going to equal twice of that because I have that area here and I have the area over here. So p equals 2 times 0.0294, or it equals 0.0 approximately 588. So this is our p-value.